This might feel a little bit strange because the unit up till now has all been antiderivatives, but they were antiderivatives of things we knew how to take the derivative of. So we'd already learned how to drive forward with all the other functions, and then we were driving backwards. Inverse trig functions we have not taken derivatives of yet. We haven't even gone forward. So today we're going to drive forward, we're going to take derivatives of them, and then tomorrow or Friday we'll worry about going backwards. So today our brain sort of switches back to, I'm not antiderivative, I am derivative, taking a derivative. So a big part of today is chain rule. Like that's always part of what we need to think about when we take derivatives. There is enough space here to derive, that's maybe not the best word in this situation, but derive the derivative of each of these. It's kind of tedious to do all of them. The first one is kind of the easiest one. So I'll derive the first one. I won't expect you to know how to derive it, but just to show where it comes from, that'll give us the first rule. And then for the second and third rule, I'm not going to derive them. I'll just leave them alone and just give you the answer for them. I think that'll save us time, and once you do one of them, it's not something you have to do. It's kind of interesting, so we'll do it once. All right, consider y equals arctan of x, the inverse tangent of x. If y equals arctan of x, then if I took the tangent of both sides, or if I wanted to sort of undo that, it would be the tangent of y equals x. Right? That's what an inverse is, switching x and y. So instead of y equals tangent of x, I've got x equals tangent of y. Well, the rule for tangent is the tangent of an angle is opposite over adjacent. So let's put this on the triangle. Y would be an angle, since we're taking the tangent of it. And then opposite over adjacent, if I'll put x over 1, x over 1. And while we're here, let's go ahead and find the missing side. A squared plus b squared equals c squared. So that missing side is the square root of x squared plus 1. Okay, so now I've got a picture that matches this statement. The tangent of y is opposite over adjacent, so the tangent of y is x. Okay, so I've got a picture that goes with this original equation. Next, let's take the derivative of both sides. So we're going to take the derivative of tangent of y, and we'll take the derivative of x. Oh, this is called implicit differentiation. We haven't done this in a while. Chain rule, chain rule, chain rule. What's the derivative of tangent? So forget about the y part. Just what's the derivative of tangent? Secant squared. Derivative of tangent is secant squared. We don't change the argument, so it's still secant squared of y. But chain rule means I need to take the derivative of the argument. So the derivative of y would just be dy dx. And what about the other side? What's the derivative of x? One. Okay, let's see. Big picture here, we're trying to find the derivative. I want dy dx. That's what I'm looking for. So I'm pretty close. In fact, this actually turns out kind of nice, because if I move secant squared to the other side, I guess I could write it as 1 over secant squared. But there's a much nicer way to write 1 over secant squared. What's 1 over secant? The same thing as cosine. So this is the same thing as cosine squared of y. But if I start with y equals arctan of x, I don't really want this as an answer. And I've got a picture here. The cosine of y is adjacent over hypotenuse. Right, cosine is adjacent over hypotenuse. So 1 over square root x squared plus 1. But then we're supposed to square it. And well, that works out nice because the square and the square root cancel each other out. So dy dx is 1 over x squared plus 1. Okay, let's see what we just figured out here. Y was arctangent of x, so what we just did was take the derivative of arctangent. So the derivative of arctangent is 1 over x squared plus 1. You don't have to know how we get there, but you do have to know what the answer is. You do have to know we're going to add 3 new derivatives to your bank of derivatives here. So the derivative of arctan is 1 over x squared plus 1. Again, you have to know that. You don't have to know how to get there. The next two, it kind of follows the same thing. Arc sine would be 1 over x. But we're not going to go through all of that. I'm just going to give you the answer. Derivative of arc sine is 1 over square root 1 minus x squared. Again, it kind of follows the same steps if you really wanted to derive it. And then lastly, the derivative of arcsecant is 1 over. So they have some things in common. They're all 1 over. Secant, you would think, is the worst out of the 3 like major trig functions, or tangent, sine, and secant. You would think secant is the worst, and you would be right. Absolute value of x, x squared minus 1. So these are kind of a pain because they're similar enough to get confused between the 2 of them. Or between the 3 of them, I guess. Because 2 of them have a square root. 2 of them are negative. Both the minuses have a square root, so those go together. But the order is backwards. 1 minus x squared minus 1. And then secant's got this absolute value of x sitting out front. Tangent is normally one of the more complicated trig functions, but for arctan, it turns into one of the more easy ones. So this is hard. Like there's not an easy way to memorize those. I would say arcsecant doesn't show up a whole lot, so I would not prioritize that. I mean, you're going to see it on the test, but for the AP test, so I'm going to highlight all of them. But when it comes down to it, tangent and sine are much more frequently seen. Okay, flip it to the back. I guess the good news is that's it. There's nothing more. It's just those 3 things. Look how many stars there are. It must be really important. Okay, the first column we already did those. 1 over x squared plus 1. Arctan is the easy one. Arcsine, they all have 1 over, so at least I get that started. Arcsine and arcsecant both have a square root. Arcsecant has that extra absolute value out front. I'm trying to show how I remember them, because I sort of have to do all 3 at once. If you just ask me for one of them, I kind of have to write all 3 of them down and figure out who goes where. Let's see. Arcsine is the one that's 1 minus x squared. Arcsecant is x squared minus 1. How I remember that, I don't know if this will help you or not, but the graph of sine is always between -1 and 1. So you can do 1 minus something small and take the square root of it. Arcsecant, remember those are the big U's off the top and the bottom? And so arcsecant is always bigger than 1. So the x needs to come first, or else you're taking the square root of a negative number. I don't know if that's more than you care to know, but that's how I remember which one is which. Sine is a small value, so I can do 1 minus small value squared. Secant gives you big values, so I need to do the big value minus 1. All right, the good news is the relationship, let's see, how do I phrase this? With all the other trig derivatives, what was the relationship between tangent and cotangent, sine and cosine, secant and cosecant? Like, right, remember if you memorize these, then what did you change to get to these? Did you remember? You changed the negative, and you changed all the sines to cosines and the tangents to cotangents. I don't have any tangents and cotangents. All I have to do is change the negatives. So all the cos are negative. Everything else is the same. And again, I don't really have those memorized other than how they relate to the original. And so if we're not in the unit on this and you ask me for the derivative of arc cosecant, like you call me up in the middle of the summer and ask me for that derivative, I'm going to say, yeah, give me a minute, because I'm going to basically have to make this whole table and kind of think through what goes where, and then I'll put the negative on this one, put the negative on that one to come up with it. So this might be one of those tests where most of the things you have memorized well enough to use them quickly, but this might be one where when I give you the test, you write down this little table at the top, and then you don't have to worry about remembering it, right? Like, do all your thinking at once. Who's positive, who's negative, which order are they in, which ones have the square root. Like, do all of that at once, write it down, and then you can use it after that. Oh, thank you. Memorize these. So there's no way around this one. This is more rules you have to know. Now, I will say this, the good news is, once you know these, you don't really know them yet, when you know these, then what we do tomorrow is we're going to go backwards. So I'm going to give you the answer, ask you to integrate it, and your answer will be arctangent or arcsine or arcsecant. So you've got to know these so that you can go backwards. I mean, it's the same as all of them. You got to know the derivative of natural log is 1 over x, so that when you integrate 1 over x, you know you get natural log. Like, you've got to know all the rules well enough that you can drive forward and backwards. Today we're driving forwards. Tomorrow we'll put it in reverse and go backwards. Okay, so some practice problems. If f of x is arcsine of x squared, find the derivative. Arcsine is 1 over square root of 1 minus... Now, be careful, I didn't put u's in there, but there is a chain rule thing going on here. So it's 1 minus argument squared, and then chain rule times the derivative of the argument. So always and forever the chain rule. So 2x over the square root of 1 minus x to the fourth. Because our argument wasn't x, our argument was x squared. 2, arcsecant. Okay, the 3 is just going to be out front. I don't have to worry about that. Arcsecant, I mean, yeah, the answer is right there, but I'm trying to think without looking at it. I know it's 1 over. It's the one that has the absolute value of the argument out front. And then the square root. And for secant, the argument comes first. So 2x squared minus 1. And then, one more thing. This is where it's really easy to forget the chain rule, because this was complicated enough, but now I also need to remember to include my Tootsie Roll Pop thing. What's the derivative of the argument? 2. So there needs another 2 in there from the chain rule. That's fine, what's written there as an answer. What else could we do? You can take a constant out of an absolute value because the 2 isn't being affected by the absolute value. So those 2's could cancel. Again, you would only do that if it's multiple choice. Excuse me. If it's on your own, you would leave this as a safe stop and not worry about who cancels and squaring things. But if it's multiple choice, it's going to clean it up. And hopefully you can figure out the cleaned up version. Number 3, arctan of the square root of x. And maybe you want to write that as x to the 1/2. That way it's easier to take a derivative of it. Although it's easier to square it if it's just the square root of x, so whichever. So the derivative of tangent. Tangent's the easy one. It's just 1 over argument squared plus 1. So 1 over argument squared plus 1. But chain rule, I need the derivative of x to the 1/2. So that's 1/2 x to the negative 1/2. And that's a safe stop, right? Like, there's more algebra simplifying to do, but if you're allowed to leave it, right? Don't mess up something that's fine as it is. Now, a multiple choice is going to clean that up a little bit. Let's see here. So that 2, I'm going to put this 2 and square root of x sort of in the front, and then x plus 1. This became this. Hey, random big picture question here. Why don't any of these have a plus c on them? Alan? Right. Plus c comes from taking an antiderivative. When you put it in reverse, sometimes the plus c or the plus c shows up. We're taking derivatives, so we don't have to worry about plus c's. But again, this is one of those places where you don't need it, but some people, like, I guess I overemphasize, don't forget the plus c, and so they start putting plus c's on derivatives. Like, no, not there. Number 4, x arctangent of x. What's going to be needed for number 4? Product rule. So, hadn't done that one in a while. So maybe, and plus arctan is new. So, usually I just product rule in place, right? 1 times the derivative of the other plus vice versa. I think this one maybe I should slow down and label some things here. So I'll call the first one f and the second one g. Derivative of x is 1, that's easy. Derivative of arctan, that's the easy one, 1 over x squared plus 1. And now I just need to put it all together. So first one times the derivative of the second one. Again, the order doesn't matter because you're going to be adding. First one times derivative of the second one. So x over x squared plus 1 plus the second one times the derivative of the first one. Oh, that's kind of a weird answer, but product rule was one of the things we needed for that one. Number 5, write an equation of the tangent line. So when I see that, my brain is automatically thinking point and slope. I need a point and a slope to do that. The slope will come from the derivative. In fact, the derivative at that point. They give me the point, so that's nice. 2/3, comma 2 pi over 3. But now I need the slope. So the slope would be y prime at that point. So dy dx arc secant. Again, I'm trying to do this without looking at the formulas. 2 is just along for the ride. Secant is the worst one. So it's the one that has the absolute value of the argument. It's got a square root. And then I'm trying to think, is it x squared minus 1 or 1 minus x squared? Because secant can get big, it can be x squared minus 1. Or argument squared minus 1. It's maybe a better way to say that. Argument squared minus 1. And then chain rule. Derivative of 3x would be 3. That's a safe stop, except I don't really care about safe stops because I got to plug in 2/3 to figure out what the slope is. So I may as well clean this up a little bit. 3's will cancel. And then the square of 3x is 9x squared. And then they want me to put 2/3 in there. Come on. Fractions. So 2 over 2/3. I don't need the absolute value anymore because 2/3 is already positive. Square root of 9 times. If I square 2/3, I get 4/9. Oh, that worked out. That worked out okay. All right, the 9's will cancel. 2 over 2/3 square root of 3. Right, that wasn't as bad as I thought it was going to be. What else could we do to clean that up? I'm going to multiply the top and the bottom by 3 to cancel that 3, so I don't have a fraction in a fraction. And actually those 2's could cancel as well. So all of that gets me 3 over square root of 3, which I can fix. Although that is a safe stop. You can use that number, that's fine. In fact, you could have just used all of this, right? You could have you can write the equation of the line and use that big chunk of ugliness as the slope, and that would be fine. So if you get worried about, simplifying, then write your equation, y minus 2/3 equals slope, and again, you can put that whole chunk of ugliness in for the slope. X minus 2/3. But I'm going to clean it up, and I get just the square root of 3. So it looks a lot cleaner, but if you had plugged in all of this right there, that's fine. That's sort of a safe stop slope that you could use. So if you get something ugly and you're worried about reducing it, You don't have to. You can use it. Now, again, free response versus multiple choice. Multiple choice, we're going to clean it up and get it down to something easier to deal with. All right, one more, and then we'll do some of the worksheet together. What is the slope of the line tangent to the graph? Okay, so that's just fancy talk for find a derivative. Arctan of xy equals arcsine of x plus y. What? At 0, 0. Okay, well, xy looks terrible, but let's hold off on that. What's the derivative of arctan? One piece at a time here. Let me back up. We're going to take the derivative of all of this. So we're going to have chain rules and product rules and all sorts of things. So arctan is 1 over, I'm trying to start as far left as possible because I know I'm going to have chain rule things. 1 over argument squared plus 1. Argument squared plus 1. That's the derivative of arctangent. But now I need to do chain rule on x times y. So that's 1 times the derivative of the other. So x times dy dx plus y times derivative of x is 1. So that's lovely. On the other side, I guess the only nice thing that's coming is eventually I get to plug in 0, 0. So hopefully we wipe out a whole bunch of stuff after we're carefully take our derivative. Okay, arcsine, that's 1 over, arcsine has a square root, and it's 1 minus argument squared. And then chain rule off of x plus y. Well, that's not too bad since it's addition. It would be 1 plus dy dx. That's about as bad as we can make it. Again, the only nice thing is now we get to plug in 0, 0. So you could solve for dy dx first, and that's usually my inclination is to do the algebra first, but not if I get to plug in a bunch of zeros everywhere. So let's plug in zeros and see what happens. So 1 over 0 plus 1 is 1. 0 times dy dx goes away, and we're left with just y. So the left-hand side became, whoops, it didn't even become y because y is equal to 0. So the left-hand side became 0. That was nice. The right-hand side, 1 over square root 1 minus 0 plus 0 is 0. 0 squared is 0. 1 plus dy dx. Okay, so the left-hand side, all of that's 0. Running out of space here, but I'm almost done. 1 over square root of 1, that's just 1. 1 plus dy dx. So all that work to get dy dx equals negative 1. Man, that's an ugly one there. All right, today's assignment's worksheet 5. We got a lot of time left, so let's do some of it together. Kind of get us started here. Differentiation of inverse trig functions. And I think, because this is what I would do on the test, derivative of arctan, I would rewrite them all. Let's see, now I'm trying to do it from memory here. Again, I don't have these memorized well. I have to sort of do them all. Arctan is the easy one. So 1 over x squared plus 1. Arcsine is kind of the next easy one. 1 over, there's a square root. And the sign of a number is small, right? The sign is always between -1 and 1, so I'm going to do 1 minus x squared. And then the derivative of arcsecant, that's the worst one, 1 over, that has that absolute value of the argument. And then the square root. Secant can be big, right? Secant is the u's off the top and the bottom, so that means I can do x squared minus 1. Again, we said all those already, but just writing them down helps put them in your brain one more time. Okay, why don't you just try number 1 and number 2? Slow and easy to start with here. Try 1 and 2.